Hello, ladies and gentlemen. Hello, world. This is Tokalebenya, Wamudikeng Wamujakisane, Mailegang Matelo, software developer at BitCube Tech. Tonight or today, I'm going to be speaking about a pretty interesting and a bit complex topic titled Generic Implementation of Tenancy, which sounds a little bit like a bit of a mouthful. So let's break it down a little bit and go through the official documents, Microsoft documentation, in order to try and understand a little bit of what we are actually going to be looking at today before we start with any coding activities. Okay, so let's have a look at multi-tenancy to begin with. The official definition on the Microsoft docs is many line of business applications are designed to work with multiple customers. It is important to secure the data so that customer data isn't leaked or seen by other customers or potential competitors. These applications are classified as multi-tenant because each customer is considered a tenant of an application with their own set of data. So in a nutshell, or to a little bit of a layman to some extent, what that basically means is that you are able to host one software that is catering for many customers, and with every customer experiencing it as if we had published a copy for each one of them. So supporting multi-tenancy, there's a couple of ways that we can do it. The first one is the discriminator, where we can use a column, and in our example we're going to be using Microsoft's Entity Framework Core ORM to achieve this. So it has got a feature called global query filters. We're going to have a look at it again in a little bit, which has multiple advantages. You just use one column, you use the same database, you don't need to have multiple schemas on the database to achieve this, which makes publishing and other processes in the pipeline much easier than what they would be otherwise. Database per tenant, so this would be publishing a database for each tenant or customer that you do have, and then you can also take the approach of having a schema per tenant, which is not supported by Entity Framework Core. So we're not going to be using that. We're going to be looking at the global query filters. I think if you can go through the documentation, you can maybe understand a little bit more and see some examples on how they actually achieve this. So having a look at global query filters, which is what we're going to be using, in a nutshell, I'm not going to go through that explanation on there. I'm going to a little bit of a layman explanation, which is basically Entity Framework's feature of trying to implement automatically where clauses to queries without having to explicitly do so on certain entities or models. Okay, so if we have a look at the Microsoft documentation on how to achieve the global query filters, just scrolling down a little bit more, we're going to use a similar example, which is an application for creating blogs and blog posts. But we're going to go a little bit in more detail, a bit of a step further, in order to show how we can actually implement it generically in a manner that it is a little bit more safe. And as we add more entities that may need to implement this, what we call a tenant or a client, that is going to be done explicitly, and which is going to be minimizing a whole lot of data leaks. So having a look at the Microsoft example, in this example we only have blog and post, and we can see a private field there which is a tenant ID, and basically how you would go and implement that is on model creating of your model. You would go and implement that such a blog which has a tenant ID field would actually go and automatically query that tenant ID and make sure that we're only returning those blogs that belong to that particular tenant ID. So that is the approach that we're going to go with first, and then we'll see how we're going to extend that. So there's a couple of prerequisites to fully understand a little bit more what we're going to be looking at, which is what we're going to go through in a little bit of a faster pace in order to just get to the point of the application a bit quicker. So we're building this application on .NET 6, the web API project, using Entity Framework Core, a little bit of knowledge on reflection, and a little bit of experience or knowledge with Postman a little bit. We're not going to go into much detail into those topics that I've just mentioned now. And then you will probably hear me just referencing ReSharper, which is a static code analysis tool, a little bit a few times, which is an extension that I will be using in this application just to help me to generate some code a little bit faster in some instances. Okay, so moving forward, let us start first of all, have a look at our database structure and try to understand a little bit more what this application that we're designing is all about. Okay, let's have a look at our database design so that we can better understand exactly what our application is going to be doing. So at the core of this application is the tenant, which is the client, which is the table that is going to enable us to be able to share a single database but experience it differently across multiple customers. A customer can add a blog category, but also as part of our system, we're going to be shipping it with some default categories that we think the customers are going to be needing or using. Customer can add a blog, which they can have multiple posts per blog. So if we have a look at our code at the moment, just start to code now. We've already created, in the name of time, just a template that is a web API, just with a couple of folders, just a default weather forecast controller. And also we have a program CS, which would traditionally have been a startup.cs in the previous versions of .NET Core. So we're using .NET 6 currently, and we're just going to need to install a couple of dependencies. First and foremost, some libraries that we're going to be needing. Going to use NuGet Package Manager to get those packages. The first one we're going to need to try and find is Microsoft Entity Framework Core. Okay, which is exactly that one. Just install that. Click OK. I accept. And then the second package that we're going to need also is Microsoft entity in memory. We're going to be using an in-memory database just for demonstration purposes. Okay, click install on that one. Okay, so once our packages have been installed, that's the only tool that we're going to be needing. Just go to the install tab to make sure that those packages have been installed successfully. Alright, then we can just run our application quickly just to see if everything is working and we are able to access that weather forecast, which is the default one that comes with the template. Just to test that our application is running correctly as it should. Okay, our application is running correctly as it should. As we can see, we have one endpoint, which is the weather forecast one, but we're not going to be using this at all in our application. We just wanted to test and see that our application is actually working. Okay, so moving on, the first thing that we want to do is to go and add our model, so to configure our ORM. In this example, what we're going to be doing is we're going to be going with the approach of putting everything in one file, which is something that we probably don't want to be doing in a production application, simply because of complexity. So we're just going to be adding just a folder. We're just going to add a folder. Just maybe use ReSharper with that. It's normally quicker to find the stuff that you really want, and I already know what the shortcuts for that is. So you can just maybe call it data or something like that. So through this section, I'm going to fly a little bit. Those are the prerequisites that I did mention at the start of the video, that it will make a little bit better if you are familiar with those certain topics. So what we're going to do now is just going to be adding our data model, our data context, which is the one we're going to be interacting with directly to get our data, to access our data from the in-memory database that we added. So just going to add a class there, and we can call it something like data context. Okay, and that data context is inheriting DB context, which is the context from Microsoft Entity Framework Core. Okay, so moving on, what we further need to do is we just need to define all of our entities. We just need to go and define all of our entities, which we've already had a look at. So I'm just going to copy and paste all of that, and we'll just have a look at exactly what I went and I pasted. So having had a look at that database schema, we can see here the entities that I've added: tenant, blog category, blog, and post. So we just added it to the same file here, so we can have everything in one. Just one thing to note over here is that everywhere where we want to implement tenancy, we've got a column called tenant ID. One thing to notice is that only two entities at the moment, blog category and blog, have got this tenant ID, but we can notice that on blog the tenant ID is not nullable, but on blog category the tenant ID is nullable. So that is very important to note, and the reasons for that is that on blog category, whatever has been added by the admin of the whole system is going to be available to all tenants, and tenants are going to be able to add their own blog categories as well as needed for their domain, in whichever domain that they are in. And with the blogs, each blog has to have a tenant, has to belong to exactly one tenant, which is why that is not nullable there. Right, so the next thing is for us to just add the DB sets for those entities that we have added, so that we can be able to access them and interact them for the queries we need. And the next thing is to just ensure that we can configure that DB context in the program.cs. So we just need to add it to the DI container. So what we're going to be doing there is we can just plug and play it there, just adding that service, that DB context. So that's that DB context that we've just added, and we want to use in-memory database. We're going to call that database tenancy, and the next thing that we do want to do next is to just seed some test data, pardon me, so that we can be able to see if our application is actually working, it's accessing the database, and so on and so forth. So under the DB context, we can just plug and play that in on here. Basically what we are doing here is that on our application startup, we just want to seed some data into this database. What we've seeded so far is just two tenants, and just added some blog posts, actually not blog posts rather, but blog categories. Just two things to note there. One blog category belongs to the first tenant, the other two are the general ones who belong to every tenant, and then we also added another blog category that belongs to tenant 2, and also seeded some blogs, one to each tenant, and also seeded some posts, pretty much one to each blog. Save changes on that, and we can just run up our application quickly just to make sure that nothing is breaking on there. Okay, so that is a bit of an error there, so let's go and fix it. Let's see what that error is about. There's something that we definitely forgot in the to add in our data context. So if we go to our data context, we are initializing. Let's just have a look at that error quickly just to explain what that is about. So we are initializing we're adding that in our container, effectively initializing an instance with options, which is a DB context options builder. But if we have a look at our data context here, there's actually no constructor that we defined that accepts that parameter. So we're just going to create a constructor there quickly, which accepts options, and then I think that error should be gone now. Okay, so that looks good. That means our application is at least passing the startup code, so that is good. Our context has been added correctly, as it should. So the next step now is to add just a test endpoint, which is going to help us to query this data and show us on Postman if we are able to access this data or not. Then we can play around a little bit with tenancy on that. So we're just going to add that controller in controllers. We can call it something like general or something. Can just call it general control. Okay, so we've got our general controller there. Again, we're just going to put every endpoint in this controller. It's just for testing purposes. In an enterprise application, we will probably just want to ensure that we separate that out a little bit. So we've just added our controller now. We want to add a couple of endpoints, which we are going to use Postman to query and just make sure that our configuration on the DB context is talking nicely to our in-memory database. And then that will enable us to just see a couple of results on the tenancy that we're going to be playing around with. So the first thing we want to do is just to add a constructor, which we're going to import the DB context. So what did we call it? I think we called it data context. Okay, cool. So we're going to dependency inject. So data context, just name it data context. ReSharper is telling us there that we need to name it a little bit better, actually title it a little bit better. So introduce read-only field there, and yeah, get rid of basically the first endpoint. So we're going to add our own one, which is going to return blog posts. So public IEnumerable, we want to return IEnumerable blogs rather than blog posts. Let's just name it something like get blogs. Okay, so our function is going to complain because at the moment it's just not returning anything, but also we just want to add maybe an attribute to explicitly say that we want this to implement what is it, HTTP GET, and then we're going to give it an alias of blocks. Okay, pretty simple. All we want to return is blocks. So underscore data context dot blocks dot, we want to include block categories, sorry, and also we want to include blog posts. I think we just named it posts. Okay, just like to format my code a little bit for a little bit easier readability. So, and then save that. Then let's add categories also. So these are the two main entities that we have implemented tenancy on. So we just want to play around with those and see that we're getting the correct results as desired. So public enumerable, I think it's blog category, you can name it, get blog categories. And again, simple one-liner, return underscore context, block categories. Okay, so those are the only two endpoints that we're going to be adding and playing around with. That should be sufficient enough for what we are trying to achieve. Let's run our application and see what we get back. Hopefully no errors. It does take a little bit of time to compile, but not so bad. It's a fairly small application that we have. So now we have a general controller again, but we just noticed that we've made a small mistake there. We have one endpoint that is listed under that one, so we just need to ensure that we add here again HTTP get our attribute to the other endpoint, and we can name it something like categories. I think that should be descriptive enough. And the next thing that I personally like to do is to ensure that on my controllers I prepend, and this helps with some versioning as well. I prepend a root category where I can specify that every root under this I want it to be prepended with the controller name. Okay, just missing square brackets there. So each endpoint here, the blogs one for instance, will be the controller name, which is general, so it will be /general, whatever the domain is, /general /blogs. Okay, and then the other thing that is missing is that we just need an attribute there also to say that this is an API controller. Okay, then we can just restart our app again. and ensure that everything is still running correctly. Okay, so we have two endpoints under our general controller, which is exactly what we wanted. And I think in Swagger there was a way that you could try it out. Actually, yes, we can try it out in here and execute. And then here we can see what our response is looking like, but I'm just going to stick to Postman on that one. Just need to check what the port is. I've already set up a couple of tabs to make it quicker for us to go and test. So switching over to Postman, we can go and do a HTTP GET request. Could not get response on there. I think that might probably be HTTPS. So let's just pay attention to that. Yes, that's configured with HTTPS. I think that's probably why my port changed also. On the default status okay. Yes, now we have a status okay on our application, and we can note there that this is exactly how we seeded our data. So we got these categories. The first category, as I had pointed out, belongs to tenant 1. The next two belong to every customer or every tenant, and the last one belongs to tenant ID. So you would imagine we would be calling this endpoint on the UI to display, when you are creating a blog, to display all as a drop down to display all the categories that are available to you. So if you're going to call this endpoint and you are going to be seeing, let's say for instance you are the first tenant 1, all you want to see is this one and this one and this one. You don't want to be seeing the second tenant's data. So this is a problem. This is a problem that we are having here. Okay, data is leaking. In technical terms, the data is leaking between tenants, which is something that would be very bad and very a bit embarrassing if you're going to be having that sort of application. I would imagine you're not going to have very many tenants because they will be upset the whole time. It's a major security issue. So what can we do here? We can add a query. We can just use link to filter it out to say, okay, let us only bring back data for tenant ID equals to 1. We're just going to hard code that. For instance, let's just assume that that would come as a parameter from somewhere. Or in this case, what we also want to do is we want to get that tenant where tenant is now. So not has value. Which would definitely serve our purpose. So let's just restart that application again. I believe our application has started, and if we query that endpoint again, we will see that this is exactly how we intended it to be. Okay, but this is not an ideal situation. What the code that we have here is not ideal, because imagine we have many places where we are querying blog categories, developers are going to forget to add that where clause where we just need to implement tenancy and make sure that we are not going to be displaying data we're not supposed to. We're not going to be leaking data across tenants. And also dry principles. That would not be very good design, because we would be repeating ourselves all over. And if that business rule did change for somehow, then we would need to change it in a lot of many other places. So that is not ideal at all. We don't want to do that. So that is where global query filters come in. This is where global query filters come in. So this is a feature of Entity Framework Core as had explained previously. And we're just going to check exactly how we would implement that. We would just need to create an override function called on model creating. So let's just add that quickly. So on model creating, just going to copy and paste that code quickly. Just going to copy and paste that code quickly. So just hard code tenant 1 for now and say we are on the first tenant. Just going through the code that I just pasted now, what we want to do is we want to add that query filter so that whenever we are querying this entity called block category, by default we implement this filter. So that would add it to the where clause of whatever query you would be running on your database. Okay, so essentially that's the where clause that we had added, but we have now removed it from the general controller. There's nothing explicit there. Then we can restart our application and see what results we are getting. Okay, application is definitely running. If we query those categories again, we can see that we are getting the results we are desiring. Tenant is the first one, and also the 2 results that belong to every tenant that can be accessed by every tenant. So we're just going to go on and implement that again for our other tenant entity, which is the blog. But the only difference with the blog is that we said on the blog, a blog has to belong to a tenant. So just for completeness sake, I guess, just for testing sake, we can actually let's stop that. It's already built. That was very quick. So let's have a look at that other endpoint also to make sure that we're getting consistent results. So what I will do here, I had already set up on my Postman also this. It needs to be HTTPS. I had already set up this Postman. So if we have a look here, if we query our blogs again, we have the first block, tenant 1, which is correct because we are on the first tenant, but also we're getting data from the second tenant, which is what is not ideal. So adding back that query filter again, you notice the difference, as I explained I think a couple of times in this video, the major difference between the two. I just wanted to demonstrate that you can have global data also. So on this one, that is not nullable. Just hovering on there, you can see that is not nullable, so there's no need to check if that is null or not. Okay, so just to have a look again, general blogs. Did I actually restart? I think I didn't restart. I didn't restart the API after adding that tenancy. Okay, using Postman again, it's just a personal preference. You can use that web page that you do get back, that's generated by Swagger. So we can see here in our query now we only have one blog, which is the one that is belonging to the current tenant. So the next step now is that it's not ideal in any application to be hard coding tenants like that, because if the same application will be used by multiple tenants, so each tenant we need a way somehow, whether through a JSON web token or something similar, to be able to identify them using claims or something like that, to be able to dynamically know whoever is querying our API at that point, to be able to know which tenant they are belonging to. So this hard coding would not be ideal. To resolve that, we just need to add some sort of a service, and I'll explain to you now exactly what we're just going to be using there, but it's going to be simple in an enterprise application. Just going to stress again that some of the things that we are doing, or the decisions that we have taken, is in the name of getting tenancy, just talking about tenancy itself rather than everything around tenancy. So we're just going to use a HTTP headers to identify which tenant we are actually serving at that moment, at that point, per request. So what we need to do is we can stop that application. We can add a folder services. You can just name it services. Actually, I added it to the wrong level there. I want to add it to the topmost level, so I just need to so that is just added to services there, not needing that CS prod. Just going to add a class. We'll name it tenant service. And in our tenant service, again, I'll just paste some code that I had already written, just to make things a little bit simpler or quicker, but we will go through the code together just now to explain. So we've got a private property, private getter, it's a public getter, so that it is available outside of this class, that is going to tell us which tenant we are actually working on or we are serving at any particular point in time in the application per request. And we just added a constructor which accepts HTTP context accessor instance. So it will give us the instance of that interface which is already in the DI container as part of the framework, and that is going to give us access to the headers, and we're just going to use a header called tenant_ID, and if we can get it, it will just set that public property. And if it is not set, it's not part of our request, then we are going to get this exception to say it's an invalid tenant. So we don't know who we are serving, so we are not going to give back any data to anybody. The next thing is to register this class or this dependency in a DI container. So what we just need to do is to extract an interface so that we can be able to add it to our DI container. So iTenant service, right? We go back to our program. And we want to add it as a scoped. We want to add it as a scoped service. Sorry, so we just need to builder.add scoped. Actually that's builder.services.add scoped. Okay. Allow that to import. So basically what we just did here, we added it to our DI container. I'm not going to go through dependency injection to any extent in this video. I think that would be a topic for another day. That would probably be a video on its own. But basically what we are saying in a nutshell is that per request, we want to spawn out whenever we need iTenant service a new instance of that type of a class. Okay, so where we're going to need to use that service is in the data context. So we'll add it there as a parameter in our constructor as a dependency. iTenant service, and just need to add a read-only field to our class. Then let's just run the application and test it. Now, because of that I have added, okay, there's a bit of an error with the application. Let's go through it. Some servers are not able to construct it. The service descriptor. Okay, we're gonna need to stop here. Gonna stop this here.
Oh, okay.
3, 2, 1. Okay, so what we're just missing here, I made a small mistake on the tenant service, that service that we need the HTTP context accessor. we just need to register it in our DI container. I was just under the impression, or my memory, I thought it was already part of the framework, but we need to add it explicitly. So going back to our program, we just need to make sure that in our DI container, the framework knows exactly where to get that HTTP context accessor. So add HTTP context accessor. Okay, that was my mistake. Our application should run. So we just need to add it anywhere before that. So that our dependency injection can run correctly. Okay, so our application is running. If we go back to Postman and we run this query, we should get an error. We're expecting to get an error, which is expected because we have not specified which tenant we are actually working on. So we are not going to give any data back unless we know exactly which tenant we are working on that request. Okay, so what we just need to do is that HTTP that HTTP header rather, we just need to specify with every request that we are working with tenant 1 or tenant 2 or tenant 3 or whichever tenant we're working on. Okay, so if we run that again, that is gone and we can clearly see tenant 1 that we're working on. And if we change that to tenant 2, actually we are not there yet. We only added that service, but we have not used it anyway in the query filters. So we're just going to go back to our data context. We've already added that dependency. We just need now to replace that hard-coded tenant with our now tenant ID. Okay, run that application again. Okay, that is running. Now, because we've specified tenant 2, we are getting results for tenant 2, and we can clearly see there that there's only one block belonging to tenant 2. And if we change that to tenant 1, exactly the results that we desired. And if we have a look again at the other query for categories, we're just going to enable that tenant ID. Sorry, that is actually a query parameter there. We're going to enable that header, starting with tenant 2, for instance. We can clearly see null tenant belonging to everybody, and there is the second tenant there, tenant 2. So we don't have any results for tenant 1. And if we change that to tenant 1 again and we run our request, you can clearly see tenant 1, null tenant, null tenant. So our application is working well, and we've achieved our goal that when a new developer does come and they're not exactly aware of what business rules that we are running, then we know we have safeguarded our application. Global query filters will kick in, and we should always get data according to the tenant. So that is good and well, but the purpose of this stream is to try and take it a step further, because now can come a problem that perhaps we want to add many entities in many enterprise applications that I have worked on personally before. You don't always only have 2 entities. That is a very, very tiny application. You're going to end up with, sometimes it can be hundreds of entities that you add as you go. And you also want to safeguard that a little bit using interfaces, using generics, and a little bit of reflection also, just to make sure that you want to take it a step further, that when we are adding any tenant applications going forward, we are able to happily say that we are not going to be having any data leaks, and those are going to be implemented automatically. Okay, so let's have a look. Let's take it a step further. I hope you have been following so far. If you have not been following, don't panic. This recording is live, but it will be uploaded exactly the same as what was recorded live, and you can go back a bit, have a look at some of those docs that I had opened, and try and see if you can follow a little bit more, try and see if you can understand those prerequisites a little bit better. So moving forward, we just need to open our data context again. Now, in terms of consistency, which is something that we try to achieve, each new entity that we want to add that implements tenancy, we want to do exactly the same as this. We want to name the column exactly the same, so that when we need to find those, we are able to do so. So using interfaces, just want to start with tenant. So if we can sit down as a team of developers and say, okay, as part of our review processes, for instance, each entity that implements tenancy needs to implement a certain interface, which is going to help us with consistently naming, number one, and the second part will be also to help us with generically or explicitly implementing tenancy on those entities. Okay, so let's us have a look. Let's have a look at, for instance, block category. So this one is an optional tenant. Just to add an interface for that, I'll just copy and paste that. Then I'll just define everything in the same file. It's related there. But yeah, you can imagine that this can potentially go very, very, very big, which is not what we want. We would then start to break it down in different files. But if we have a look at defining an interface, we can perhaps call that iTenant, which has a property called tenant ID, and every entity that we are implementing that is actually what we want to do there is this one is the non-optional one. So iTenant, which would be block block, for instance. So we just need to implement that interface like that, and we'll just copy and paste that again, but we'll just name it something else. We'll maybe call it INullable tenant. Okay. Which only has one member, that is nullable integer tenant ID. So each entity would then, if tenancy applies on it, we would then apply that either one of those interfaces. Okay. So what is this going to help us? How is it going to help us from a code perspective? It's going to help us to get rid of this. It's going to help us to get rid of explicitly implementing this repetitively like this. So let's say, for instance, we were adding another entity, I'll just call it tenant entity. Let's imagine we added it here in our DB sets and so on and so forth. It's a new table that we are adding, and it is nullable, and it implements that this interface INullable tenant. So we would exactly be coming here to copy and paste this. So we could literally have hundreds of these entities that we want to implement tenancy on, which would be very repetitive. Okay, so that's not what we want. So let us have a look. How can we go and identify all of those entities and add tenancy without having to remember to do so? A little bit of reflection. So I've already got a little bit of code that I have implemented, okay, in the interest of saving a little bit of time on this video. If we use a bit of reflection, you'll notice that there's a couple of errors there, but we will go through the errors and resolve them as we go. Okay, so the first thing we want to do is we want to find all of the entities or classes or entities that are implementing iTenant to begin with. We want to get all of them. I'll explain that in a second, what exactly that is, but we're just going to be writing a function that will get all of those entities that are implementing that interface, and we're going to loop through each one of them, and we're going to implement that global query filter to that. And this function we still have to write also. But that is basically in a nutshell what we want to do there. So let's have a look at this get implementing types. Again, to better understand this code that we're going to be writing now here, you're going to need to have little prior knowledge of reflection. I won't go into much detail with that. So if we just add a class there, just forgot to name that class. We can delete it quickly and add a new class. Let's add it in data. We can just an extension to simplify things, to add it into a different file, I think. So we're going to call type extensions. Okay, so our extension class needs to be static. Okay, and again, I'm just going to copy and paste some code, and we're going to go through with it together. Right, so this looks a little bit overwhelming, but it actually is not overwhelming. So we've just defined here a static function, get implementing types. Then we just also specify what type that we're going to be passing through. We're going to go through the merits of the function itself in a nutshell soon, and basically the base type that we want to get the implementing members of, if I may call it that. Okay, so what in the first line here, that generic that we're passing through, we need to know in which namespace that we are going to be looking for these entities. So we want to put all of our entities in one namespace, so that when we do define what the namespace is supposed to be, then we know we're looking for those entities in the correct place. And using the app domain class, which is part of the framework, we can get the current domain, we can get the assemblies in that domain, we can select all of those assemblies in that domain, but we want to return the types of those assemblies. We want to select the types of those assemblies rather, where the base type is assignable from that type in that assembly. Okay, and it's not an interface. We're not looking for interfaces that are implementing that interface. We're not looking for abstract classes that are in that that are implementing that interface, and we're only looking for those members in this namespace that we have specified here, and we just basically want to select that to list and return it. So that's how we get our implementing types. Okay, you will notice there that that squiggly line has gone. So just to make this code simple, move that to a extension, then we can easily read it. Get implementing types, simple. That's what we're looking for in that namespace for that class. So we know that that entity, that's the namespace that we are looking in. Wherever that entity is in, we're looking for everything in that same namespace as that. Okay, and then going through this again, for each of those implementing entities, those entities that are implementing this interface, we want to add this has query filter. Okay, now we still have one squiggly line there that we are going to be attending to. Okay, again, just going to be pasting some code, and then we're going to go through it. Okay, we can just edit this code as a private member in this class. You know, if the model was starting to get big, I think then some of the things can definitely be moved out of the class. Okay, so if we have a look at what we are saying here, this is the tenant expression. We're just writing a function, private function, that brings back a lambda expression, which would be applied to that query filter for each model. Okay, so what we are looking at now is a parameter. So it's a parameter expression that we are getting from expression.parameter for that entity type that we are looking at. So in our case, it's blog. It will be for each blog. That's the only one that is implementing iTenant so far. And we just need to define an expression of type func, of type iTenant, which is exactly that interface that we are implementing, and returns a boolean. So using an arrow function, it takes in the entity itself and basically defines what that query filter is going to be looking like. Okay, so we want in that entity that implements iTenant, we want to query the tenant ID to be equal to the tenant service, but I think I named it maybe something else here. I named it iTenant service, which is definitely not a standard naming convention. So that would just be tenant service, just going to refactor it using resharper. So that would be tenant service. Yeah, we just want that entity, that field tenant ID to be equal to our tenant services tenant. Okay, so that would loop through each one of those. Okay, so if I go and I go to blog and I comment that out, that implicit query filter, and actually rely on this functionality going and finding the implementing types, which should find the blog, and looping through all of them, currently just being the blog at the moment, and implicitly applying that query filter that we already know for each of the non-nullable tenancy. It's going to apply it in that fashion. Okay, then in this function further, we just replace the tenant filter that we have generated, the parameter of the tenant filter that we've just created now. We replace with the new parameter, and what do we replace? We replace the body, and then we return a lambda expression. So that is how we would actually create a lambda expression after having replaced those. Okay, then if we run this application, and we query our blogs, we are only expecting data for tenant 1 only. So let's test it out. Tenant ID 1, that's the first blog. There's no other blog. So the other blog for tenant 2 has been omitted. So we know that that function of ours, or that functionality actually, because it's a group of functions, is working as expected. So we just want now to do the same for the other interface, which is where's the other interface? We just want to do now the same for the other interface, which is nullable tenant. So we want to apply similar, so that when we do have another entity that is similar and is using the same rules, we can implement it generically and implicitly in that fashion. Just going to paste some code again. It's very similar to the code that we just played around with now, that we just pasted, just with different rules. Okay, so if we have a look at this, and our interface now has changed. It's not tenant anymore, it's the nullable tenant. We want to deal with those, and that generic, remember, that is not the entity that we're looking for. We're just using that in our code to get the namespace, that type to get the namespace, so that we can search only in that namespace. And we just used on this example, we just use blog because all of our entities are in the same namespace. So I think if you did have multiple namespaces, then you would, use that. We could have easily used blog category there on either of these, just to get the namespace. Didn't want to hard code that namespace. That should still work exactly the same way. Okay, so we just need now to define what that query is going to look like, which is a function for the nullable now, because it's got a different rule. Again, we're just going to copy and paste that. We're going to put it directly beneath the other one. So the only difference in those rules is exactly the same. If you can compare top and top, exactly the same what we worked with, but the only difference is the rule, how we actually created that tenant filter. So a little bit of repetition on both of those functions, but I think in terms of possibly simplifying what is already a little bit of an advanced topic, I'm not going to go through to refactoring that and making sure that we only factor perhaps in a different function or a different service or whatever, exactly that is only different between the two. So we will just leave the repetition as is for now, and I think perhaps that refactoring can be a topic for another day. So let's go and test it again now. We're going to comment that out, and we rely on the fact that we're going to be covering everything that is implementing that nullable tenant. So let's just test it for the last time. So what this would be covering is just one entity at the moment, which would be the blog category. Okay, let's have a look at the categories, blog categories. Tenant 1. Okay, that looks like it's working to me. Tenant 1, the first one. The second one is the global one. The third one is the global one. There's no category for the second tenant. Okay, switch over to tenant 2. Global category, tenant 2. So now we know that that is working, and as part of our review process as developers, we can discuss that. As part of our review, if we add an entity that needs a tenancy, all we now need to do is just to implement the correct interface according to whether it's nullable or it's non-nullable, and everything should work from there. Thank you so much, ladies and gentlemen. I hope you enjoyed this video. I hope you learned something. Feel free to revisit it again and just follow the concepts and follow the code and follow the concepts until you can be clear with it. Thank you so much and have a good evening. Goodbye.